Today we're going to talk about linear regression and how we can use our calculator and different tools to help us talk about linear regression. So the first thing we need to know is what a scatter plot is. A scatter plot is a graph that relates two sets of data by plotting all of the points. So we've plotted all of these ordered pairs, and you can use the scatter plot to determine the strength of the relationship or correlation. We will use that word correlation between the sets. So we're trying to figure out if they correlate or if they have anything to do with each other, if they have a relation. So when the data plots are closer together along a line, they are said to have a stronger relationship. So let's look at these and determine if they have a strong relationship or not. So these points are all pretty close together, so they have, along a line, they have a strong relationship. These points, I can kind of see a line here that they're all decreasing, but they're not really very close together. So I would say they have a weak relationship. Now these points right here, they're all over the place. I can't see a line forming any way, like they're not increasing, decreasing, nothing. There's not really any sort of pattern. So these ones would have no correlation. Oh, my pen's running out. Okay. Then the next ones, again, these are grouped a little bit more together and they look like they're kind of increasing, so I'm going to say they have a weak correlation. And this last one, they are grouped tighter, and you can see that they're heading up, and so these, since they are grouped tighter, would have a strong correlation. So when they're grouped tighter, they're going to have a strong correlation. When they're not as grouped, but you can still see a pattern of either increasing or decreasing, would be weak. And when they're just kind of all over the place, that's going to be no correlation. Now the next thing is we need to talk about if they have a positive or if they have a negative correlation. So depending on if they have a correlation that is going from the top to the bottom, that would be a negative correlation. So see, like if you drew a line of best fit in here, that would be a line with a negative slope. So these have a negative correlation. So in all, these have a strong negative direction correlation. Now these have a weak correlation, but we can still also see that it's kind of going in the negative direction. So weak negative direction correlation. And the next ones, again, we said had no correlation, so we're not worried about if they're positive or negative because they don't have a correlation. Over here, we see a weak correlation, but as you can tell from this grouping, they go from kind of lower on the left to higher on the right. That is going in a positive direction, so we say it has a weak positive correlation. And the next one as well, you can see it's going from lower on the left to higher on the right, so that is going to be a positive correlation at all also. So if you put a line in there, like a line of best fit, and it would have a positive slope, that would be a positive correlation. If it would have a negative slope, that would be a negative correlation. So down here, it wants us to know, for any correlation, people often assume that if one thing changes, then the other thing would change, but that's not always true. So for the following situations, I want to know, A, what correlation, if any, is there between the quantities? And B, do you think that a change in the first thing makes the second thing have to change? Makes it have to change. Okay, so the number of miles driven and fuel expenses. Well, let's think about that. If I take my car and drive more, assuming I'm the one paying for gas, does that increase my fuel expenses? Yes, it does. So, if this is increasing and this is also increasing, would that be a positive or negative correlation? Well, let's look up here as the x's increased or went to the right and the y's increased or went to the right, and the numbers did both of those things, so went more right and more up, more right and more up, that kind of looks like this one. So it's going to have a positive correlation. So for a positive correlation, as your x's increase, your y's increase also. Okay, so then B wants to know, do you think that a change in the first quantity causes a change in the second quantity? Well, if we drive more, does that mean we're going to have to use more gas? Yes. So does that mean our fuel expenses will go up? Yes, also. Okay, now down here, the size of a car's engine and the number of passengers it's designed for. So the size of a car's engine, as that goes up or increases, does the number of passengers it's designed for increase? Well, let's think about that. There are small passenger cars that have a big engine, and then as you get bigger engines, you can have bigger vehicles. So like a bigger engine, but it might be a truck, and a truck might not hold as many people as, say, a minivan, which would have a smaller engine, or a semi-truck would have a very large engine, but it's only designed to carry few people. So I would say that this is not necessarily true. There's not necessarily a positive correlation here or a negative correlation, because you can have different size engines, and that doesn't necessarily increase or decrease how many passengers, because like we said, you can have like a school bus, which would have a very large engine and very many passengers, or you could have a semi-truck which has a very large engine but is only designed for a few passengers, or you could have like a little Yaris or some small vehicle that has a smaller engine, still designed for 4 passengers. So I just don't think there's any correlation between the size of an engine and the number of passengers it's designed for. So then B says, do you think a change in the first quantity causes a change in the second quantity? Well, if I increase an engine, so let's pretend you have one of the older muscle cars, and it has like a 350 engine in it, and you want to increase your engine, well, does that make your number of passengers increase or decrease? No. A change in your engine is not going to change the body style of your car. So 3A, the number of cassette tapes a person owns. And if you don't remember what a cassette tape, or don't know what a cassette tape is, that's what we used before DVD or before CDs. So the number of cassette tapes a person owns and a person's age. Well, the more cassette tapes you own, I'm going to guess the older you are, because I'm guessing none of you own any, and I think I own maybe 1 or 2. But I think my mom owns more than that. So I believe this is going to be a positive correlation. But does the number of cassette tapes you own, if you buy more cassette tapes, like you get them on Amazon or something, if you buy more cassette tapes, does that mean you get significantly older? Well, no. Buying more cassette tapes doesn't have any effect on your age. So since these were both positive correlation, let's talk about negative correlation. So when you have a negative correlation, your first quantity or your x's would increase, and your second quantity or your y's would decrease. So let's think about some things that can happen here. You may think about your own, but I'm going to just throw some out there. Take, for example, if I eat more, what will happen to my hunger? So as I eat more, my hunger decreases. And what about if you exercise more? If you exercise more, what happens to your weight? Well, depending on a lot of other factors, but generally, if you exercise more, your weight will decrease. So that's how we tell about correlation, positive, negative, and then you'll have to look at the scatter plot to tell weaker strung. So let's look at this one. Down here I've got some utilities, and it says the table lists the monthly temperature and the electric costs for a Texas home in 2008. So here's the month, here's the temperature, here's the electric cost. Now it's kind of confusing because this chart really should be down here. It's a continuation, but they put them next to each other to save some space. So the table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? Okay. Well, in order to do this, we've got a little grid over here that we're going to make a scatter plot on. So the first thing we need to figure out is what we are going to label these axes. Well, which one does someone have some control over? Can we control the temperature? No. So the one that we cannot, the one that is kind of chosen for us is the average. That's your independent variable. The one that, the one that is kind of either chosen for you or you can pick and put it into something, that's your independent variable. The one that depends or will change based on this first one, that's your dependent variable. So our average temp is going to be our X, and this is in degrees Fahrenheit. So it looks like we go up into the 80s, so I probably need to get at least to 100. So if I start 0, 20, 40, 60, 80, 100. Good. Okay. So I'm going to go, and these, remember, are all in degrees Fahrenheit. So then that makes this one is going to be my electricity bill. And this is measured in dollars. And it looks like the biggest one here is $255, so I should probably maybe try to go up to 300. Okay, I'm going to count on this one by 25s. Now I should probably do these the same, but I'm not going to. Actually, wait a minute. What am I going to do? Let's see. Let's see, if I do 300 here, 250, we'll go by 50s. 200, 150, 100, 50, we'll make this 0 down here, but that one will be 25. Okay, so 0 is not drawn in, but it's right there at the bottom. Alright, now let's plot these. So January, I need to go right 61 and up 150. Let me pick a different color. Right 61 and up 150. So it'll be right about there. Then February, I need to go right 58 and up 139. So right in there. March, right 67 and up 172. Then April, right 75, so halfway between 70 and 80, and up 205. May, right 79, just before 80, and up 170. That's 175, so just below that. Oops, my 172 is above that. Move that down just a smidge. Okay, June, right 83, up 234. July, right 84, up 255. August, 85, up 245. And September, right 81, up 210. October, right 76, up 183. November, right 65, up 132. And December, right 58, up 110. Okay, so we've got all those on there. So does it look like they're moving from, as the x's increase, so as I go from left to right, so as I go across here, are my y values increasing also? Are they going up or are they going down? Well, as I go from left to right, so as I travel from left to right, my y values are definitely increasing. So these are going to have a strong, these are going to have a positive, they're going to have a positive correlation, because as I go from left to right, they're going up. And then you can tell they are grouped together pretty well, so they are going to have a strong correlation. So since they're grouped together, that gives them a strong correlation. Moving up from left to right gives them a positive correlation. So strong positive correlation. Alright, so on the back here, I have a lot of things written on here. So you can choose if you would like to pause your video now and write these down, or if you would like me to walk through the calculator steps and then later pause your video to write them down. You choose. Okay, so the first thing I'm going to do with you is we need to do a setup step, which I actually forgot to write on here. So up here at the top, write this down, we need to do a setup step. So, to do this step, you are going to take your calculator, you're going to turn it on, and you are going to hit second, and you are going to hit catalog, which is 0. So, second, and down here, catalog. And after that, you are going to hit the arrow down. You are going to hit the arrow down until you find Diagnostics On. It's in D. Diagnostics On. You do not ever have to do this again once you do it one time. So second, 0, then hold your arrow down until you get to Diagnostic On. So hold your arrow down until this little arrow is next to Diagnostic On. Then press enter. It will say Diagnostic on your home screen, and you hit enter one more time. And it will say done. And once it says done, your diagnostics are turned on, and now you don't ever have to do that step again. Okay, so how we are going to do this is we are going to use our graphing calculator to find our line of best fit. So we will be given a table of values, and since our years are really big, but they're all after 2000, when I put this into my calculator, just to give me some smaller numbers, I'm going to do the years since 2000. So how many years since 2000 is 2001? 1 year. 2002 would be 2 years. 2003 would be 3 years. 2004, get it? So how many years since? So if you need to, you can take each of these and subtract 2000, otherwise just look. So when I put these in my calculator, I am not going to put 2001, I'm just going to put 1. So this is the year, and this is the price per pound of rice produced in Texas. So we got this, and here's our source, because we like to cite when we get stuff. So how we are going to do this, to find the line of best fit, we are going to let x equal the years since 2000, so we already have that. So now let's grab your calculator and again turn it on. Now you're going to follow along on these steps with me. So the first step, and my calculator has covered it up, so hopefully you have it written down, or you will write it down later. The first step is to press the Stat button. How you find the Stat button is you find the green alpha button and move 2 to your right. Press that Stat button, and we want number 1, edit. So you can either press the number 1 or you can press enter here. On the directions I have press number 1, so that's what I'm going to do. When you do this, when you do this, you will get a list. And some of you may have some stuff in your list. If that happens, go up to the top, press clear, and then press the down arrow. So let me show you again. And you can hit the right and left arrows to migrate between lists. So if you have numbers in your list, press the up arrow, clear, and the down arrow. If you are up here with the list name, do not ever hit delete. Do not ever hit delete. If you do, then that list will go away and you'll have to bring your calculator to your teacher so we can make magic and make that list come back. So if you put in the wrong number though, let's say I put in 5.2 and I didn't want that, I needed 5.3, you can highlight that number, press delete, and it will disappear, but that's only when you're making the list. When you're up here, clear only, never delete. So when you've highlighted the L, clear only. Okay, sorry, back to what we were doing. So we are in our list and we are going to enter our data. So it says, yeah, I've covered it up, but it says our x's are independent variables, so they are what we can either select or what has already been given to us. So it is the it is the year. So we enter the years since. So 1, 2, 3, 4, 5, 6, 7. And to enter those, you just press the number, then hit enter, and that will take you down to the next one. Press the number and then hit enter, and it will take you to the next one. After that, we are going to arrow to the right, hit our right arrow, and we are going to enter our price per pound of rice. Now it's kind of hard to see it, but this first one starts with a decimal. So it's 0.461, enter. 0.735, enter. 0.735 again, enter. 0.777, enter. 1.0, enter, and 1.13, enter. Okay, now, always double check your lists, because I messed up somewhere. Oh, there was 2.461s. Okay, do you see that I made a mistake? And that's a good thing that I did, because as you can see down here, see how there's a 7 and then that's blank? That means my lists do not have the same amount of things in them, and if I tried to go any further from here, the calculator would say, error, dimensions don't match, I can't do anything, this is not okay, and it would not let you go any further. So, as you write this down, put a star under number 1, and I always want you to double check this step before continuing. Okay, because the calculator can only act on the information that you've given it, and if you've given it wrong information, then everything will be wrong. So always double check. So I've got my data entered. There we go. So to make the graphing calculator make a scatter plot, and again this is a setup step that you're only going to have to do this one time, and then after this you won't have to, hit second and y equals, and you'll get all of these things. Now hit enter, and I need you to select on, so make sure it's highlighted, on this scatter plot symbol, and then make sure these say L1 and L2. And then you can select any mark that you want. I'm going to make mine, I think I'll just leave mine as the box. Okay, so make sure on, scatter plot, L1, L2, and this mark. If you need to change these to different from L1, if this is something different, L1 and L2 can be found on top of number 1 and 2. You have to hit second to get to them. Okay, if you need help with that, come see your teacher. At any point, if you cannot figure out where a button is, or if you have any questions, pause your video and go ask your teacher. So now that I have all of this stuff selected, second quit. Okay, so when you turn your calculator on, this is your home screen. The only way to get back there, if you press y equals or you press something else, the only way to get back to your home screen is to hit second and then mode, which does second quit and takes you back to the home screen. So now that we're on our home screen, to see our scatter plot, because we've got all of our data entered, to see our scatter plot, you must hit zoom. So on this top row of buttons, the middle one is zoom. So press zoom and then the number 9, and that will show you our scatter plot. So then over here in my scatter plot box, I am going to draw this scatter plot. That's pretty close. Okay, so I've drawn my scatter plot, and you will always need to draw your scatter plot. So whatever it says on the screen, sketch it into a box and call it your scatter plot. You can label X and Y, that would be great. So now we're to step 4, and we need to get the regression equation. So this is why we turned our diagnostics on. So again, we're going to go back to Stat. We are going to arrow to the right, so we have Calc highlighted. And then there's all of this stuff that shows up. Well, we are doing regression for linear, a line of best fit. So if you look at number 4, it says linear regression. That's what we're doing. So either press number 4, actually let's just do that. Press number 4, and then it will say Lin Reg across your screen. Once you've got that, press enter, and all of this stuff shows up. So all of this stuff is kind of confusing, but what it means is we have an equation. And our equation is in the form y equals ax plus b. So y equals ax plus b. Then it tells me what a and b are. Do I have to write out that whole number? Yes, you sure do. So on your quiz, you would write y equals, and then you would write the number that the calculator gave me for a. So all of that thing. So 0.1148928571. And then after A comes an X plus B. And B is 0.291. So on your quiz, that's what we would want to see. Now MathExcel is a little bit different. Instead of saying y equals, MathExcel I believe has an r equals, but it wants the same information. It wants that entire decimal, but then instead of an x, MathExcel uses an a. I'm not sure why. Okay, so in MathExcel, when you use that equation, you're going to put an a. On your quiz, it's y equals mx plus b. So it's kind of confusing. Okay, so we've got our equation, and we've written it down. Here it is, or in MathExcel, we'd put that one. Now, I want to see the line of best fit on that scatter plot. So there are 2 ways to do this. If you have the Lin Reg on your screen, see it says Lin Reg? If you have that on your screen, you can follow these instructions on step 5. Hit y equals. If you have anything in there, hit clear. So these are all blank. Make sure this plot 1 is highlighted so we can still, that's telling me my scatter plot is still on. Make sure that's still on. Now you're going to hit vars. So from stat, go down 1 and right 1, and there is vars next to clear. Now on vars, we are doing statistics right now, so I need statistics, number 5, and then we are going to arrow right 2 times until that EQ is highlighted. Then I want the regression equation, so I'm going to press number 1. So now you see in y equals, the calculator has put that equation in there for you. And notice it has a little bit more information for B than it showed us on the screen. That's okay. So if you don't remember those steps, you can always just grab your equation and start typing 0.114892857 and then X is right next to your green alpha key. So you would press X right here. Plus 0.291. So you choose. Either follow the steps for number 5 or type it in yourself. Oh, I didn't arrow down. Darn it, Mrs. Black, what were you thinking? Okay, so once again, with the linear regression on the screen, you hit vars, number 5 for statistics, arrow right 2 times, enter, oops, nope, I skipped a step. Hit y equals, vars, number 5, arrow right, regression equation. Now it's in there. Okay. Then if you hit graph, it will show you the line of best fit in your scatter plot. So we can go up here and add that to our scatter plot, and yes, you need to do that. So go up and add that line to your scatter plot. Hopefully you made it a little straighter than I did. Okay, so that is our, that's how you follow through on the calculator directions. So then in lime green here, I just said if you forget these steps, just hit y equals and type in the equation, and I showed you how to do that. Okay, so if you didn't write it all down before we started, pause your video now and write down all those steps because you are going to need them. Alright, now finally, on B, it says using your linear model, which is right here. This is our linear model. So that's what we're going to use. Predict the value of rice in Texas in 2015. Okay, well, we need 2015, and back in our chart, 2015 is a year, so that would be an X. So for 2015, I know that's an X, but remember we're not using the entire year, we're just using the years since 2000. So X is going to equal 15. So in my long equation, yes, I do need to use the entire equation. Y equals 0.1148928571 times 15 plus 0.291. So grab your calculator. Second quit to get back to the home screen. You can clear it or you can leave that stuff on there and start typing in. Oops. After you've typed everything in, hit enter and it should tell you 2.014392857. But again, this is a word problem, so we need to answer in words. So what does this word mean? Well, it says predict the value of rice in Texas in 2015. So you can say rice in Texas in 2015 cost. Okay, now how much of this number am I going to use? Well, 2 would be dollars, 0.1 would be the cents, and then does 4 round this up or down? It rounds it down, so $2.01 is how much rice cost in Texas in 2015. Okay, now on C, it says using your linear model, so again, this model that I found in part A, predict when the price is likely to reach $2.60 per pound. Well, $2.60 is money, so back on my chart, my X values were years, Y values were money, so I am going to place this amount in for my Y. So 260 is going to go in for my Y. So I'm going to write this equation again, but instead of writing Y, I'm going to write $2.60 equals, and the whole thing. Okay, so then the first thing I need to do to get X by itself, because that's what I'm trying to do, is solve for X, would be subtract 0.291. So then I would have 2.309 equals this whole thing. And then I'll need to divide by all of that, and I'm not going to write that out. But I do need to do that in my calculator, so 2.309 divided by 0.1148928571. Hopefully I didn't make a mistake in that. And when we do that, we get 20.09698478 equals x. Okay, well, so what does that mean? Well, this is an x, and if you look back on your chart, x was the years. So if x equals a year, we're not going to use decimals because it's a year. So x is going to equal 20. And remember though, it's not just 20, it's the years since 2000. So if it's been 20 years since 2000, we do 2000 plus 20. So it would be in 2020, rice cost $2.60 per pound. And remember that you get to skip the decimals because it's a year. Okay, so that's your answer. In 2020, rice cost $2.60 per pound. Oops, that's kind of off the screen. Alright, so one more time, if you didn't write that all down, I'll move it to the center so you can pause and write everything down. Good luck on your Math Excel assignment.